and it just is going to send voltage through your finger basically. And if you're lying, typically you'll start kind of sweating a little bit on your skin, and so the resistance will go down, so the analog value will go up. And so that's kind of the way this really simple lie detector works. So here's the code for it, really simple. I'm using the analog read pin 2. Then I'm just doing a serial begin. This is just a function that lets me output whatever is happening on the Arduino over serial. I can just do a serial print, which then I do down the void loop. So I do a serial print of whatever I read in through the analog read. And then I delay for 5 seconds, then it's just going to keep reading. And so I can just watch that value go up or down. I can know what's going on. It's not perfect. Any emotional response will actually trigger you sweating like this. So if you're mad about what the person's saying or something like that, then you're also going to look like you're lying to these lie detectors. And also the professional ones all have things like they test for heart rate and breathing rate and things like that. So here's another one that there's a ton of people who make different versions of this. So all you do is take a laser, you put it across a doorway, and then on the other side of the doorway you have a photoresistor that the laser's pointing at. And so when someone goes through that laser, it's going to change the value that's being read on that analog read to that photoresistor, and it's going to show you that someone went through, and you can buzz or do whatever you want to trigger on that person coming through. Here's one that the follower talked about yesterday that he did, which this is one of the first projects that I made as well, actually going off of his plans. So this is based on the AVR project VUSB. So it's a simple circuit. It has just 3 resistors, 2 diodes, and then just the USB connector, and that's it. And you can emulate a HID device. So you can do a keyboard, and then when you plug it into a computer, it's not going to need any drivers. It's just going to work. And it can be modified to be like a joystick or a mouse or a lot of other devices. So security uses for this, there's been a couple other talks. Adrian Crenshaw and Fowler, they talked about this a little bit, doing things like you connect it to a computer, and then when a person comes and logs in, then it can, while they're turned away or something like that, then it can add a user really fast without them noticing. Another use that I thought about using it for was you hook it up to a kiosk, a computer that's in a kiosk mode, and have it just go through all the possible combinations of keys and try to break out of that kiosk mode. Typically in the past, a lot of kiosk modes have special keys that they forget to exclude from being able to get to things in Windows or something like that. But check out Adrian's or followers talk about this as well. They did some good stuff. So here's the schematic. It's, like I said, it's really simple. It's these 3 resistors, 2 diodes, and then the USB connector, and then to the Arduino. And then the code, basically, so you have to disable the built-in timers in the Arduino because USB uses different timing. And then you just connect as a USB device, and you can just start sending keystrokes. So it's super easy to do. The next one that I decided to do is one of the ones I decided to do wasn't next after that one, I guess, but at some point in my life I decided to try to make an RFID emulator. It's actually, part of this was because I wanted to get Chris Paget's that he was supposed to make after last DEF CON, but he never came out with it. So I thought, well, I'll see if I can make my own, see how hard it is. So I wanted to emulate 125 kilohertz RFID tag. I didn't have an oscilloscope or any kind of antenna tuning equipment, and I didn't have any plans to do it. So there was no, here's how to make an RFID emulator with an Arduino or anything like that. There's some similar projects that gave me a lot of help, but there was nothing like right there so I could just take it and use it. And so this is what I ended up coming up with. So this RFID tag spoofer, stupid simple, and Hackaday and Make ended up picking it up and doing stories on it. So all it is just a 10 kilo ohm resistor, transistor, 10 nanofarad capacitor, and then a spool of wire and a spent roll of toilet paper. So, and the code is 20 lines long, so it's really easy to make this thing. So I'll actually demo it here in just a minute, but here's the schematic. So you have, and it didn't take me very long to figure this out either. I think it was like 6 hours or something like that. So these are actually really easy to make. So it has the resistor going to the Arduino pin, then to the base of the transistor, then the emitter and the collector are connected to the coil, and also has that tuning capacitor that goes in between them. And so basically what happens is, I've wrapped this antenna so it's at the right frequency, and so the RFID reader sends out a carrier wave, and my antenna is tuned so that it will respond as basically a high whenever the RFID reader sends out the wave. But then what happens is with this transistor, when I put power to the base, it essentially connects those two ends of the antenna that are connected to the emitter and the collector. And so that detunes that antenna, so it gives it a low signal. So it's really easy to make this thing work. So the code, I'm using pin 9. I just chose a pin. It doesn't matter which one you use. And I said it's going to be an output pin because this is the one I'm going to use to turn on and off the antenna to detune it and tune it. And then I just started out as low. And then, so the way that RFID works, I just got this off of Wikipedia. It uses Manchester encoding. So this just means it has the clock signal, then it has the data, and they get XOR'd, and that's what you end up sending back. So that way the clock and the data is in one signal back. You don't have to have separate ones when you're sending the data. So here's my main loop of my code. So basically I just define my data that I'm going to be spoofing. So you have to send it a bunch of ones so that it knows that you're a valid RFID tag. You're not something just giving interference or something like that. Then you start sending it the signal, and so in this one I'm just doing all F. So I'm just doing four ones, and then the 0 is parity, and then at the very end there's all those zeros, which is the column parity. So it has parity on the rows and the columns. And then I just call this function that I defined called set pin Manchester. And I just give it what the clock is and then what the data is, and then it just does all the XOR stuff, and it then changes the pin. I delay for 256 microseconds, so I'm at 125 kilohertz, and then I just keep repeating. So you just set so here's my Manchester code. So as you can see there, I'm just XORing the clock and the signal to get my man encoded int. And then if that's 1, I know that I should set that pin low, because low is going to be high on the antenna because I'm not joining those two ends, detuning the antenna. Or I set it high and that detunes the antenna, and then I get my, then it's going to give a low signal. So here I'll really quickly show how this thing works. So to demo this, I'm just using the Parallax RFID reader that Joe Grand developed. He just came out with a new one that's a reader-writer, and then here's my spool of toilet paper with wire around it. And the antenna just has to be the right tuning, so it doesn't have to be around a thing of toilet paper. But that just was easy for me to do. So here's my code, and then let's see. And that's the ID as well. It has a built-in serial monitor, so you can do serial stuff. So as you can see here, hold a tag up to it, it reads it. Hold another tag, it reads it. Then I'm going to hold this thing up, and it's just doing all F's, right? So I can change that code, I can modify it, and it can output whatever I want. And so I can emulate any ID with this device. Goes off. Okay. So now the next thing another thing to look at too is when you're building hardware devices is what other stuff can you interface with. And so serial is a good way to interface with things because it's really easy to do. A lot of stuff supports it. There's the digital I/O pins 0 and 1 are hardware serial pins, so they're easy to connect to stuff. There's also, like this Parallax reader uses serial. GPS units use serial, LCDs, various integrated circuits, a lot of stuff uses serial. And the second one is I2C, or I2C, which is analog pins 4 and 5 are built-in I2C pins. This is a bus protocol, so you can have up to 128 individual devices on this bus. And each device has its own address, so that way you can interact with the one you want. So there's like the Centipede shield. This is what it uses, which gives you a ton of I/O. I think it gives you an extra 64 I/O per shield, and you can stack them. Also, the Wii Nunchuck, it uses I2C, and I have an LCD that does either serial or I2C. So you can connect the Arduino to whatever device you want and try to, just send stuff over serial or listen over serial, see what's happening, and figure out how stuff works. I actually used this to fix my neighbor's Seagate hard drive. It looked like it was going dead, and so I Googled and found out it has a serial interface on the back of it, so I was able to connect to it and change and reset the hard drive, and it works perfectly now. So it's kind of interesting that even hard drives have that on them. So like I said, Wii controllers, and there's also an I2C scanner, which will just scan everything on a bus, see what's there. So like I said, there's a Parallax RFID reader. It's a serial device. It runs at 2400 baud. Really easy to use. Here's the code for it. So basically with this one, I wanted to be able to use the hardware serial to report back to the computer, so I ended up using the new soft serial library, which gives me basically bit banging serial, so I can use any of the digital I/O pins to do serial. And so then I set up so this is all the code right here, so it's super easy to do. I include the new soft serial library. I tell I'm going to use pins 6 and 7 for RX and TX, and then I start up my serial, which is the new soft serial one, and I set up my serial, which is the hardware built-in one, and then I basically what I do is anything that comes in from the new soft serial pins I just forward out to me, so that's how I can see that up on the screen, things like that. GPS tracking device. So this uses a serial GPS unit. I got this off Spark Fun. Can log data to an SD card, or it can broadcast it out using cellular or XBee or something like that. So you can use it to track down stolen goods. So I know people who have devices like this they put inside their golf bag or whatever, and then if someone steals it, they just go and beat them up or whatever. And then and also it can see where people are. Like I have a cop who lives next door to me. He says that they put these devices on cars and they can track where they're going. They have to have, in Utah at least, they don't have to have a warrant to do it. They just have to have reasonable cause that there's something suspicious going on. So, but as far as me doing it, I don't know if it's legal or not. So. Another device is this Blue Smurf. It's really cool. So it's a serial device. It basically replaces a serial cable with Bluetooth. So if you have two Bluetooth on each side, then it's the same as a serial cable between the two. So default data rate is 115K. It can be used to program an Arduino if you just hook it up right. Arduino is programmed over serial, so any serial device can be used to reprogram it remotely. You can also use it to communicate with other Bluetooth devices. So Fowler talked about this yesterday as well. So this is the Blue Smurf. This is a picture of a cop holding it, where they found it inside of I think a pin pad of a gas station or something like that. Which it seems a little bit silly to use this one because the range is so small. It seems like you'd use an XBee or something like that, but that's what the criminals used. So people are saying Spark Fun is bad because they made this device but it's just silly, right?
Where did they find the device?
I believe they found it at a gas station in the keypad, so you swipe your card and you put your pin in. I believe that's where it was, something like that. So one thing that's kind of fun to do with this Bluetooth is the Arduino and the Android project is called Armarino. So basically what this lets me do is I install this app on my Android phone, then I put the Blue Smurf on, then I can interact with my phone. I can make my phone interact with my Arduino remotely or wirelessly, and vice versa. So events on my phone can trigger stuff on my Arduino, and stuff on my Arduino can trigger events on my phone. So it's a pretty cool little project. It's really easy to use as well with this Blue Smurf. Another thing you can do is you wire up to an iPod or an iPhone, and then you can do serial commands too. So you can do things like dump out playlists. You can do all the remote things. The other thing that's fun to do is just try to send it just crazy crap and see what happens. See how it likes that. So another thing that I did is I used the XBee Shield, and I thought it'd be kind of cool. So I thought about two different things with a Cisco device. So I thought, well, you could either put an Arduino with an Ethernet shield inside of it, maybe use relays so that when you don't want to attack something, then it's working correctly, and then when you want to do something with it, you switch that port over so it's going to your Arduino, and you can mess with stuff. Another thing that I did with this one is I actually inside of this Cisco router, I've actually opened it up and I've soldered to the bottom of the console pins